Today we'll be looking at endothermic and exothermic reaction profiles. So let's start off with what a reaction profile is. So this will show us whether a reaction is exothermic or endothermic. It shows the energy in the reactants and the products. So it shows the energy in the reactants and products, and then shows us the difference in energy between them. So let's just write that down as well. Shows the difference in energy between them, between the reactants and the products. Shows the difference in energy between them. Now our next one is, now we're going to draw them. So first we'll look at an exothermic reaction profile. So when it comes to reaction profiles for exothermic, the first thing we need to remember is what an exothermic reaction is. So this is when energy is released to the surroundings. And that's quite important, as you'll see later on, into the surroundings. So before we start drawing the reaction profile, let's first label the y-axis and x-axis. So the y-axis is always energy, and then the x-axis is progress of reaction. Now, with this, because it's exothermic and energy is released into the surroundings, like I've said over here, into the surroundings, that means that the energy level decreases. Why? Because energy is released to the surroundings. So the reactants in the beginning have more energy than the products because energy is released. So after the energy is released from the reactants, the energy will go down. So let's just label that as reactants. And let's label this as products. Now, other stuff that we need to do over here is show the energy change and then also activation energy. So the energy change is this bit over here, the energy change from the reactants to the products. So it's this bit over here. And I'll just write EC for energy change. Now, there is also another line. So there's going to be a line from here all the way down to here. Now, this bit over here is called your activation energy, and I'll write that as AE, activation energy. Activation energy is the minimum amount of energy needed for a reaction to start. So minimum amount of energy needed for a reaction to start. And that's all you need to know for the exothermic. You need to make sure that you put the reactants at the top, the products at the bottom. You show the energy change, and then you also show the activation energy. And you also need to know the definition, which is the minimum amount of energy needed for a reaction to start, or you could say to occur. Now, we'll move on to endothermic. Now, like we did for exothermic, we'll just remind ourselves of what endothermic reaction is. This is when energy is taken in from the surroundings. So energy is taken in from the surrounding. From the surroundings. And again, let's just label our y-axis and x-axis. It's the same. Y-axis is energy. X-axis is progress of reaction. Now, if we go back to our exothermic, energy is released, meaning energy will go down. Over here, endothermic, energy is taken in, meaning at the end, so our products will have more energy. So this time, our reactants are at the bottom. And because energy is taken in from the surroundings, we're going to have more energy. So at the end, our products will be higher up. So let's just write reactants. And let's write products. And again, we can label it, this bit over here, from our reactants to products, is our energy change, which I'll write as EC. And again, you're going to have one line up all the way down here. Now this time, your activation energy is going to be the whole thing from up here all the way from down here. And again, what is activation energy? It's the minimum amount of energy needed to start a reaction. So we've gone through both of the reaction profiles, and that's it for today's lesson. Thank you.